In this video lecture, we are trying to study the interoperability concept in Model 4, that is renewable energy processes. So let us talk about what we mean by interoperability. As already you know, it is the concept which is related to the ability of two or more components which are used in a power system. They are trying to exchange the information. That information is very much essential for the monitoring as well as for the controlling of various applications of the power system. So this issue includes the interoperation of the system components, confirming the particular standard. So every component which is connected in the power system, they are communicating each other. So that communication is very much essential as far as the monitoring and controlling is concerned. So let us take the example of the PMUs, the phasor measurement units, which are situated in every part of the transmission grid. So all the PMUs which are connected in a particular network, all are communicating each other. They are sharing their information for the better control or monitoring applications. So these all components are obeying the IEC rules, International Electrotechnical Commission, that rules whatever it proposes, the standards whatever it proposes, each and every component which is sending the or exchanging the messages with another component or the machine, they are obeying these all rules. Those rules are very much essential for the communication management, security, and for executing the different applications of the power system obeying the interoperability. So let us talk about the state of the art interoperability. Usually there are basically two elements we are going to consider for the interoperability. One is the technical, and another one is the commercial. In case of technical interoperability, this will define the functionality of the gas and electricity metering interfaces which are providing the smart metering options. So the commercial interoperability, it concerns with the what is the cost of the particular component, whether that component is used commercially in all the different communication equipments or not. These all points we are going to consider in the state of the art. So let us talk about the benefits of the interoperability. So as we know that interoperability concept is very much essential in case of the smart grid, which will allow a network seamlessly, autonomously, it will integrate all the components of the electrical power system so that they can be controlled with a central grid. So this is the main concern of the interoperability. Only the point is here, it will provide the network to all the components. So the another benefit of the interoperability is it will minimize the human intervention. So which is not required. Decision making or the controlling of the every transmission or distribution grid is not at all essential. Everything is controlled by a central grid, so that manual intervention is not at all required. It will minimize the manual intervention in controlling the transmission grids. For a kind information, the maximum or 90% of the transmission grids all are controlled with without human, and only the people or the control engineers who are working in a grid, they are just maintaining the components, but they are not controlling the components. All the components of the grid are connected with the central grid. Then what are the challenges of interoperability? So very first aspect of that is whether the network enhancement is provided to all the components which are there in the power system. First condition. What is the network capability? Whether the adoption is possible to all the components or not. This is a major challenge what we have, because overnight we cannot construct a new grid which is having the network connectivity. It is necessary to provide the network connectivity to the available components which are there in the old grid. So that is the main challenge we have. Then the next part is the implementation strategies, whether those components are supporting, whether they are adopting the existing or the new technologies or not. These all are the other issues what we are going to consider. all must be authenticated and validation. So whatever the communication we are doing in between the two components, that must be authenticated, and there is a proper validation or access must be granted to every message. Then only the interoperability will be highly secured one. Otherwise, this is a problem. This is another challenge what we are going to face in an interoperability concern. Then let us talk about the model for the interoperability in the smart grid environment. The agency called as JWAC, that is the Grid-Wise Architecture Council. So it has developed one model for the interoperability, which is having the several layers. The first layer is the technical layer. This technical layer will emphasize on the syntax, what type of syntax or format you are going to provide for the information, then how you are going to send that information, how you are going to communicate that information to the other components, which type of communication medium you are going to use. These all parts are concerned with the technical layer. As far as the second layer, information layer is considered, here the main aspect is given to the interoperation, or what attention you are going to provide on the information. Then whether the same information is carried to the destination or not, whether its meaning is very clear or not. About the body of the information, the focus is very much given. Then the third layer is your operational layer. This is mainly concerned with the aspects of interoperation, especially the management of electricity. So the development of the business parts, as well as governing the policies which will manage the electricity command. So this last layer will concern about that. Then we talk about the smart grid network interoperability. As already you know, when the interoperability concept is considered with the smart grid, so there is a communication between the components. Those components are like your transformer, your PMUs, PDCs, like that. Those components itself, they are calling it as a machines. Those machines will require specific set of data or kind of data, so that instructions what we are going to use to provide that data, so to complete the one particular task. So that is very important. And the most important challenge is what type of language or the method you are going to use to design that particular point, and which type of protocol we are going to use for the effective communication between the machines. That is very important. Whatever the language we use, whichever the protocol we design for the interoperability, that must obey the standards. That is the one condition. We can use the older protocols which are already standardized protocols are available. We can use that also. We can develop the new protocol also, but that protocol must be as per the standard. The main issue is to facilitate the efficient, quick and speedy transfer of the data among the available devices. This is the main important issue as far as the network interoperability is concerned. This concept is not only limited to the physical aspect of the network, which is also considered with the what type of data we are going to deliver, whether the messages are navigating in the network or not, whether those messages are properly addressed or not, whether the messages are properly reached to the destination device or not. These are also another aspect of the communication. Then the last part of this is about the interoperability and the control of the power grid. Usually, the smart grid is the electric grid is already well protected, and it is controlled by the SCADA and EMS like traditional methods. But as far as the new application of the smart grids are considered, so these methods are becoming ineffective. So by using this, we cannot control or protect the power system. So because of that, it is essential to develop a new technology where we can control all the components of the grid are controlled centrally using the control centers, or we can share the data to the regulatory agencies, energy markets, independent power producers, large customers, suppliers, and all are, you can call it as a stakeholder. All the stakeholders must get the information about the smart grid. So this is the most important aspect. Then the second aspect is the control centers must be able to connect to the components of the of the grid with the smart technology. So this will facilitate effective performance without any interruption, or it will improve the smaller interruptions which are going to happen. So the ultimate aim of this is we are going to provide a communication touch to the regular grid, so that each and every happenings what are there in the smart grid, that must be communicated from the generation to the consumer, so that we can effectively increase the performance of the power system. So consumers, when the consumers are involved in the operation of the grid, so automatically its performance is enhanced. We can improve the performance. Consumption can be controlled. Then the communication we can make it faster. Then the effective response can be taken. Then we can, most important thing is we can reduce the faults. Power system faults can be reduced 100%, so that the security can be provided to each and everything. The overall performance of the power system can be enhanced by incorporating interoperability. So these all interoperability concept is mainly concerned with the standards. About that standard, we'll study the next video.